Good afternoon, community theater at Docker. Hello. Glad to see your faces. Not sure what's up with this row. Very popular row. If you guys are over there eating lunch, you can always lunch and learn over here at the community theater. So I encourage you to come over and snack with us. It is my pleasure to introduce our speaker, Keith Richards of RTI International. He will be speaking to you about improving the human condition with Docker, which I'm super excited about. Please help me in welcoming him to the stage.
All right, hello everyone. As introduced, my name is Keith Richards, and I'm a software developer at RTI International. Today I'm going to be talking about how we at RTI International use Docker to fulfill our mission. In other words, how we use Docker to improve the human condition. So before we get too started, we need to talk a little bit about RTI International and give some backstory. So RTI International is a nonprofit research institution based in North Carolina. We work in the social, statistical, health, and physical sciences, the engineering disciplines, and we do some international development. Most of our work is public sector, though we do some private sector work. But the one core theme to all of our projects is that they, in some way, seek to make the world a better place for society. We try to move the needle. We try to make the world better. We try to improve the human condition. Our corporate tagline is delivering the promise of science for global good. Now, specifically, I work in the Center for Data Science in RTI International. We're a team of 20 people. We have data scientists, visualization experts, software engineers, and computational scientists. Our role is to sit at the confluence of academic research and innovative technologies. So we take the work that our science staff does, their conceptual and their academic work, and we turn it into applications that people can use. We make their theoretical into something tangible. I like to say we make data come to life. So RTI International has about 5,000 employees. We have experience in 250 different degree fields. We work in 75 countries. We have 12 domestic offices and 12 international offices. We work in a whole lot of different domains. We have a vast problem set. We have a lot of variability in our day-to-day. We tend to turn to Docker to help us improve to help us kind of mitigate that variability and improve the human condition. So today I'm going to be talking about some of the projects that we work on and how Docker helps us in fulfilling that mission. So the first project I'll be talking about today is Call for Service Analytics. This is our software as a service crime analytics platform. Now, anytime someone calls 911, that call gets routed through a computer-aided dispatch tool. That computer-aided dispatch tool is used to allocate officers to calls. They pick the appropriate officer to respond to a given call. Because these tools are trying to allocate for a current event, they are inherently forward-looking. They don't really care about what goes on in the past. That's where we come in. These tools gather a lot of data and they stick into a database somewhere and it's never touched again. So our tool ingests that data, does some analysis on it, and then we gain some insight from that data. Now, specifically, this tool allows agencies, departments to make sense of this data so we can better allocate resources. One of the examples here is one of our pilot agencies realized that during shift changes, their response times would go up a lot. They didn't have enough people that were in an overlapping shift change. So if someone put a call in just before the shift change, they would have to wait until just after to get a response. Now, in property crimes, that's not a big deal. But if that's bodily harm, if someone's bleeding in the street somewhere, that's a big deal, and that's really important. So with our tool, they realized that they needed to add additional resources to that overlapping shift, and they needed to kind of spread that out a little more. Similarly, our tool allows agencies to monitor, to prevent and predict crime. So intuitively, we can see that downtown on a Friday night is probably going to have a higher crime rate. However, what happens if it's Tuesday night, or if it's Tuesday afternoon? No one really thinks of that. It's not something that we do intuitively. However, with our tool, agencies are able to see that. They can see in their data that one particular beat on one particular day of the week gets a lot more traffic than others, and they're able to adjust their staffing to meet. Ultimately, we may help them make sense of their data. So, how does Docker actually help in this project? Well, first, application demand varies a lot. Our crime analysis staff may check this tool once a day or twice a day. The CIO and the CIO staff may check once a week. the executive level, the chief of police, may check once a month. We've noticed significant spikes in our product's usage. It'll spike and then it'll die out, and it'll spike again and it'll die out. So we turn to Docker in this case to kind of streamline that, spread it out a little bit. We can, in conjunction with our Amazon Web Services auto-scaling rules, we can scale out horizontally to meet demand and then collapse in. Docker really helps us here in that the immutability of an image really gives us confidence that when we scale out, we're going to have the same thing on all of our different nodes. So our tool, we have a software as a service tool, but then each agency has a collector that's built in their network. So it's on-prem per agency. And this agent runs and it collects all of that data on a daily basis and it pushes it up to our service. We wrote this in Go out of performance concerns because we deal with a lot of data. And we realized pretty quickly that we had a lot of different agencies with a lot of different architectures, and we didn't want to deal with Go on all these platforms. So instead of trying to build Go and all of Go's dependencies on each platform and all the different variables that we may have, we turn to Docker again. We ask our agencies to install Docker, and then we can just put in all of our work, all of our Go and its binaries, all of our dependencies and code into an image and just hand that off to the server. This greatly simplifies the onboarding process, and we don't have to deal with trying to explain to someone how Go Get works. Finally, software as a service products thrive on a high release tempo. Our agencies come up with new insights, and they want to learn new things about their crime and their jurisdictions. So they turn to us to get that feature built out. So through continuous integration pipelines, through unit testing, through integration testing, and through code signing, we're able to build out our code quickly and deploy it, through a simple command and get it out to our clients as quickly as possible. Ultimately, Docker helps us improve the human condition by allowing agencies to better understand their jurisdictions, allow new agencies to come on and then for them to better understand their jurisdictions, and allow for us to deliver frequent updates more easily and with less friction so agencies can better understand what's going on. So the next tool we'll be talking about is our Crosstab Builder. This is a statistical analysis tool built in conjunction with a federal government entity. So this federal government entity, they conduct yearly substance abuse surveys. So these are anonymous surveys. They go out and they collect these surveys every year, and they pull all the results, and they do some recoding and some imputation, and they hand the results to us. We then take all of that data, and we built a tool for policymakers and for statisticians to quickly understand correlations in that data. So the case here is, as a kid growing up in the 90s, I was always told that marijuana was a gateway drug, and if you consume marijuana, you would go on to do other things. Well, with this tool, the policymakers can actually run that crosstab. They can see the percentage of the population that consume marijuana and if they moved on to other things. It's important to note that they will just get correlation, not causation, but that's up to them to figure out. And the other thing we do with this platform is we aid statisticians in quickly visualizing these correlations. So how does Docker help? Well, the surveys have a really complex weighting scheme. It's very difficult. So it requires a methodology called Taylor series estimation, which is really complicated math. Through Docker, we're able to build a service that is optimized for these Taylor series estimations. So we have one dedicated service that its whole job is this Taylor series estimation. And then we can have our web service and our front-end service just run and through a RESTful API pass data back and forth. Now earlier I said that they are nationwide surveys. These are actually state-level surveys that are aggregated at the national level. So at the national level, it's fine to just put these out there. Anybody can use them, consume them, because the data is aggregated nationally. However, at the state level, it's possible to actually filter down to small groups. So if I filter by gender and by age and by region, I can potentially kind of undermine the anonymity of the survey and identify someone. So we have some access requirements on this project that disable that or disallow that. So within our code, we have some checks that suppress results if it's a restricted use survey, if we have less than 3 respondents. Similarly, on our network level, we are required to keep all of this data in an on-prem data store. So we actually have like a hybrid cloud setup that we have our public out in AWS and we have our private on-prem. Again, we leverage the immutability of Docker here in that we trust that our code is written locally and it's deployed to either our on-prem or either the cloud, and it's totally fine. We'll have the same thing going in each case. Similarly, we can then turn to network access rules to handle the other restrictions there. Now, we have Taylor series estimation, and we have restricted use surveys. So we have a kind of a strange production environment. Through Docker, and specifically with Docker Compose, we can mimic that locally so our developers are able to go in and make changes. Our dev team can go in, they can make their changes they need, and they can have confidence that their work will adequately be reflected once they move to a production environment. So Docker helps us in this case improve the human condition by letting us efficiently calculate these crazy Taylor series estimations. We have a platform agnostic images that allow us to just run on various our on-prem or our cloud providers. And then we can also finally ensure that our developers can make changes as required, and they have confidence that the changes they make will actually work in production. So now the third product I'll be talking about today are public health microsimulations. So these are microsimulations done with the federal government to, these are specifically, one is diabetes and the other is nutrition. And these tools they exist so health economists and public health researchers can make some decisions and kind of plot out interventions that people may take. So if you ever see the studies that say if you drink less sugary beverages, you'll live longer and you'll have better health or whatever it may be, it's typically done through a simulation like this. So with our platform, we allow public health researchers and health economists to assert their validations that their interventions actually work. We allow them to come up with new interventions. And then finally, we allow them to measure the cost effectiveness of those interventions. So how does Docker help this project? The academic community really, they expect reproducibility and replicability. Once we publish to a journal, others that read that journal want to be able to run our same work and verify our claims. They want to be able to test it out. So through Docker, we bundle everything up in an image, and we just hand it off to anyone that wants to test it out. So if a researcher says, I don't believe your work, let me see it, we can just give them a Docker image and let them run it. Sorry, I should have clicked that. So the next is I mentioned the cost effectiveness of a simulation. This is typically done through what's called a probabilistic sensitivity analysis. So the way this works is in a microsimulation, we have a lot of things that we know. We know that decreasing sugar-sweetened beverages will end up decreasing sodium by a known commodity, a known amount. However, there are a lot of things we don't know. We don't really know how much it's going to cost. So what we do in this case with probabilistic sensitivity analysis is we build distributions that represent the unknowns. So in the case of cost, we might have a gamma distribution with some known parameters, and we might have a beta or a log normal distribution for the other unknowns, or other variables in this case. And then we run 1,000 simulations, or we run 10,000 simulations. And we draw from these distributions, and then we take all those results in the end, aggregate them, and then we have a mean, and we have confidence intervals around that cost, so we get a good ballpark for where it's actually going to be. Because we have to run thousands or tens of thousands of simulations, though, this is very time intensive. Again, we turn to Docker and its immutability in conjunction with Kubernetes to horizontally scale our simulation, our worker nodes. So instead of just running one that's churning out 1,000, we might run 10 nodes, or we might run 100 nodes, we might run 1,000 nodes. And we can really get through this list efficiently and effectively. And we have confidence then because, the immutability of Docker, we know that images are going to run the same thing. They're going to provide consistent results. Now, this particular platform is deployed to an OpenShift environment in AWS. Governance regulations state that we need to make sure that we are free of any security vulnerabilities, we're free of any issues. So as part of our CI process, we need to run through some security scanning. So through a combination of security scanning via Twistlock and image signing, we can scan our images, we can sign those images, we can push them to a trusted registry, and then any one of those worker nodes from the previous probabilistic sensitivity analysis, we know they will be running on something that is free of vulnerabilities because it's been tested, it's been signed, and it's in our secure registry. So ultimately, Docker helps us improve the human condition by promoting reproducible research in the academic community, ensuring public health can be validated, public health policies and cost effectiveness can be validated and properly asserted. And then we can also guarantee that our images are free of vulnerabilities, and when we build out, they're consistent, they're free, they're without any issue. Now, in addition to the projects, because we have so much variability in our work, we also do a lot of ad hoc work that we may just leverage the transients of a container, of Docker, to spool up a container that does one particular thing for one particular purpose, and then we just kill it off. So we use it for a lot of ad hoc tasks. For instance, we get a lot of proprietary data, or we get data that's in a legacy format, or we get it in some format that we're just not familiar with. We turn to Docker here to take that data and convert it into some open source or open standard that we are familiar with. So we may get some obscure data type that we've never worked with. We spool up a container that can support that data type, and we can convert it out to something that we work with more commonly. We also use Docker to manage complex dependencies and drivers. Within our group, we typically rely on cloud, but we also do have one on-prem GPU machine for training deep learning models. If you've ever trained a deep learning model, getting the GPU's driver set up is kind of non-trivial. So instead of dealing with that all the time, we turn to NVIDIA and NVIDIA's base images, and we build off of those. We let them handle the hard stuff, and we can just build our images out on top of it. Similarly, we can shield our build complexities from our engineers. Now, I'd mentioned earlier the call for service analytics, the crime analytics tool. One of the pieces of that is an automated vehicle location system that we can track where police cars are as they move through their jurisdictions, and we can get an idea for how much time is spent in a particular beat or on a road or in an area, in a neighborhood. And then we can, if we see that there are gaps in coverage, or we see one is really saturated and doesn't need to be, then departments are able to adjust. GIS libraries and getting them built out, it's a really complicated thing. There's a lot of moving parts to a GIS build. So instead of putting that into our Docker files and having our junior developers look at all this stuff, we build out a base image that has all this built in, and then we just tell our junior developers to use it. And finally, we can debug some complex problems. I don't know why that got cut off. So we can debug some complex problems through containers. So the case here, or an example here, is the public health microsimulations. When you deal with diabetes complications, there's a lot of interdependence. That an increase in cardiovascular disease also causes an increase in HbA1c levels, which causes an increase in something else, which causes an increase in cardiovascular disease. And there's a lot of complexities when we're building these out. So when we build these models, these statistical models are based on actual research that we try to take actual research and then put it into a statistical model. The complexity here, though, is when you're looking at these complications in isolation, it gets really difficult to understand how they work together. So in this particular case, we actually spooled up a graph database in Neo4j so we could illustrate just how complex that was just by putting out a graph diagram. And then it was really, our statistical modeling staff was really able to see how interdependent, how connected those things were, and they could really understand then how complicated their model was and how they needed to refine it. So in this case, Docker helps us improve the human condition by facilitating the analysis of a lot of data, lowering the barrier of entry to using some of these advanced tools and libraries, and explaining and illustrating problem complexities. With the help of Docker, RTI International Center for Data Science is able to build resilient and reliable software rooted in academic research. Docker really does help us improve the human condition. Ladies and gentlemen, thank you all for your time today. And if you have any questions or you'd like to know anything else, I'll be here for the next few minutes. Feel free to stop by. Thank you.